So equals b to n by to 2n by squared fn of x. And remember, we have by to 2n equals a to n over b to n. So this equals b to n times, yes, a to n over b to n by squared fn of x equals a to n by squared fn of x. Perfect. Now, the next step we have, what do we have in the next step? Then we need to define the function h of x. H of x equals different. It's equal g prime of x sine by x minus by g of x cosine by x. We will differentiate h of x. How to differentiate h of x? By the product rule for each term, because each term is a product of functions. So we need the product rule. Let's start. H prime of x equals by g prime of x cosine by x, using the chain rule for sine by x. Now let's continue the product rule. Plus g double prime of x sine by x. Now the other term minus differentiate g of x first. You get minus by g prime of x cosine by x. Now fix g of x and differentiate cosine by x. What is the relation of cosine by x? Minus by sine by x. So minus minus plus. Plus by squared g of x cosine, it's sine now. Sine by x. We have cancellations, right? This equals, these will cancel together. So we will just have sine by x times g double prime of x plus by squared g of x. And this equals sine by x. Remember, g double prime of x plus by squared g of x equals a to n by squared fn of x. Okay? So like this, sine by x times a to n by squared fn of x. Is it correct? Yes, thankfully it's correct. Fortunately it's correct. Now what? Now by the fundamental theorem of calculus, we have the following. By the fundamental theorem of calculus, we will apply it on h prime of x. I love calculus because I have high interest in irrational numbers. So if calculus is useful here, I love it very much. Now let's apply it. Integral 0 to 1 h prime of x dx equals what? Substitute h prime of x. So we have by squared, take the constant out, by squared 0 to 1 a to n sine by x fn x dx. Now apply the second fundamental, the second here. Oh, okay. The second fundamental of calculus. You will get h of 1 minus h of 0 because it's integral of h prime of x from 0 to 1. The integral of derivative h1 minus h of 0. And we can apply it here because h of x is continuous function. Where is it? I mean h prime of x is continuous. Now, yes. What is h of x? Here is h of x. So we have substitute 1, g prime of 1, sine by, minus by, g of 1, cosine by. Okay, now minus h0, substitute 0, minus g prime of 0, sine 0, minus minus plus by g of 0 cosine what? Cosine 0. Now let's delete each of x because we have finished substituting 0 and 1. So this equals sine pi is 0. Sine 0 is 0. We have just cosine pi minus 1. So pi minus minus by g of 1 plus by g of 0 because cosine 0 equals 1. And this equals by g1 plus g0. Good, good. So we have now the following. Where is it? Yes, here. We have the following integral equals this by g1 plus g0. Cancel by from both sides, you get the following. You get the following, like this. Cancel by from both sides. By squared, cancel one term of by, you get this. By times the integral equals g1 plus g0. But remember, g1 plus g0 is integer. Why g1 plus g0 is integer? Because this one is integer, g0 is integer, g1 is integer. Okay? Now remember this inequality from the start of this video. If n of x is greater than 0, is than 1 over n factorial, x is between 0 and 1. Now multiply both sides of this one by the following. Yes, multiply by, it will be like this, by a to n, okay, fn of x sine by x, okay, this is this than by a to n over n factorial, sine by x, okay. Why is this correct? You should ask me why is this correct. Let me tell you. By is positive. Positive. A to n is positive. Remember, by squared equals a over b. I told you earlier that I want to assume a and b are positive. So by a to n are positive. We don't have a problem with them. Okay. Next, what about sine by x? Sine by x. Our domain here is x is greater than 0 less than 1. Multiply by x is greater than 0 less than pi. Now let's see the unit circle. The unit circle here xy, y represents sine. And here in red, from here to here is 0 to pi. From 0 to pi, sine is positive. So the equality is correct. We don't have a problem with this equality. Good? Good. Now what? But this is less than or equal to by a by a to n over n factorial. Strictly less than, because x is not 1. I mean, it's not that x is not 1, but what I want to say is that the highest value of sine by x is 1. So we can put 1 instead of sine. In fact, it's not multiplying by sine by x. Sine by x, yes, it's strictly less than, yes, like this. Sine by x is less than or equal to 1. So here we have 1. We don't need to write it because 1 times anything is just 1. But why is it strictly here? Because of fn of x. Fn of x is strictly less than 1 over n factorial. So it's like this. Now let's integrate. Okay, we'll integrate from 0 to 1. So by integral 0 to 1, a to n fn of x sine by x dx is greater than 0. The integral of 0 is 0. Okay, integral from 0 to 1 of 0 is 0. It's always zero, integral of zero. Okay? I mean, if it's definite integration, it's zero, the integration of zero. Now, less than integral from 0 to 1 of this constant. So, what is the integral of constant? The upper minus lower, 1 minus 0 times the constant. So, we just have by a to n over n factorial. And we will use now a very nice tool. We proved it earlier in this video. That if a is any number, okay, we can find n sufficiently large such that a to n over n factorial less than epsilon. Okay, take epsilon to be what? To be 1 over pi. So here we get pi times 1 over pi, we have 1. Because a to n over n factorial is less than 1 over pi. And we have original pi, so pi times 1 over pi 1. So what we have proved is the following. And this is contradiction. We have this, and this is less than 1. Why is this contradiction? Let me show you why. You can see now why is it contradiction. Because of this. See? The integral belongs to integers. What are the integers? Let's write what are the integers. Minus 2, minus 1, 0, 1, 2, like this. Can we have integer between 0 and 1? No. So this is the contradiction, which means pi squared is irrational. Which means pi is irrational. Please like and subscribe this video, okay? And tell me in the comments your opinion about this video. If you reach this moment of this video, tell me that you have reached it. Tell me your opinion about the video. Write number 5 in the comments if you reach this video. Okay? Thank you. I wish you the best luck.